Ratios, fractions, and percentages all in one question. Wow, that can look a little intimidating, right? But today we're going to walk through a GCSE problem step by step and show you a really simple way to crack it. Let's get right into it. Okay, so here it is, the problem we're going to tackle, taken right from a GCSE higher tier paper. We've got Andy, Luke, and Tina, and they start by sharing sweets in a certain ratio. Then, some of those sweets start getting passed around. The big question at the end is Tina telling the truth? And, we have to show our work to prove it. So yeah, that's what this whole thing boils down to. After Tina gives away some sweets, not once, but twice, does everyone actually have the same amount? That's what we've got to figure out. First things first, before any sweets get passed around, we need to figure out exactly how many everyone has at the very beginning. Let's set the scene using that starting ratio, 1 to 6 to 14.
Now, you could jump into algebra here with a bunch of x's and y's, but honestly, that can get messy real fast. A much smarter exam technique is to just pick a convenient number for the total. Trust me, it makes the calculations a whole lot easier to handle.
So how do we pick a good number? Well, it's actually pretty simple. First, you just add up the parts of the ratio. So 1 plus 6 plus 14, that gives us 21. Now the trick is to pick a multiple of 21. Let's go with 210. Why? Because it guarantees all our starting shares are going to be nice, clean, whole numbers. It's a fantastic way to dodge messy fractions right from the start. And there you have it. With our starting total of 210 sweets, we can see exactly where everyone begins. Andy gets 1 part, so that's 10 sweets. Luke gets 6 parts, which is 60. And Tina, well, she starts with the lion's share, 14 parts, a whopping 140 sweets. Now everyone's starting point is crystal clear. Okay, stage 1 complete. Now for the first move. Let's follow the trail of sweets as they go from Tina over to Andy. Now, the wording here is absolutely crucial. This is one of those classic exam trip-ups. She gives away 3/7 of her sweets, her 140, not 3/7 of the total sweets in the whole pile. That's a really important distinction. So we need to do the math. We're going to take Tina's starting amount, which is 140, and we're going to multiply it by 3/7 to see just how many sweets that is.
And boom, there is our number. The math is pretty straightforward. 140 divided by 7 is 20, and then 20 times 3 gives us 60. So exactly 60 sweets are going from Tina straight to Andy.
So let's update the scoreboard. Where does everyone stand after that first exchange? Well, look at this. Andy's total shoots up from 10 all the way to 70. Tina's, on the other hand, drops from 140 down to 80. And what about Luke? Well, his amount hasn't changed, at least not yet. All right, on to the second step. This one throws a percentage into the mix, and it has some very important wording we need to pay super close attention to. Okay, this is the whole key right here. The phrase of the rest. It's not 12.5% of her original amount. It's of the sweets she has left over. And right now, she has 80 sweets, so we're calculating 12.5% of 80. Let's figure out what 12.5% of her remaining 80 sweets actually is. And here's a little pro tip for you. 12.5% is the exact same as the fraction 1/8. Knowing that can make the mental math a whole lot quicker. And there we go. 1/8 of 80 is 10. Simple as that. So another 10 sweets are on the move, this time from Tina to Luke. Okay, all the transactions are done. The sweets have all been passed around. It is time for the final count, the big reveal. Let's see if Tina's claim actually holds up. Let's update our table one last time. Andy's amount, no change, he stays at 70. Luke's total goes from 60, he gets those 10 sweets, which brings him up to 70. And Tina's total drops from 80 by 10, which leaves her with, wait for it, 70. How about that? They all end up with exactly 70 sweets. So, we have tracked every single sweet. We've done all the calculations, and we have our final numbers. Now, we can give a definitive answer to that original question. Let's just quickly revisit Tina's claim. She said that after all that sharing, they'd all have the exact same number of sweets.
And based on our calculations, her statement is 100% correct. Yes.
And this right here, this is the clear, logical path that gets you the full marks. We started with the ratio. We calculated those initial shares. We carefully tracked both transactions, and we arrived at the final count. The conclusion is undeniable. Yes, Tina is correct. But hang on, here's a final little thought for you to chew on. Did the total number of sweets we started with actually matter? We picked 210 just because it was a convenient number. But what would happen if we started with 420? Or even just 21? Since this whole problem is about proportions, would the end result be exactly the same? It's a great way to really test your understanding. Thanks for joining me.